Very good afternoon to everyone. I'm Dr. Madhuri Rao. I am the coordinator of today's webinar. Our speaker, Dr. Chukhu Chunka, is here. Thank you so much, ma'am, for taking out your time for us. We will begin with a short introductory video about our university. Please let me play it for you. management schemes in today is who has received Institute of Technology, Arunachal Pradesh. She did her MTech in Computer Science Engineering from Northeast Regional Institute of Science and Technology, Arunachal Pradesh, in the year 2015. BTech in Computer Science and Engineering is from Central Institute of Technology, Kokrajhar, Assam, in 2013, and her diploma in Computer Science and Engineering is from Rajiv Gandhi Government Polytechnic, Itanagar, Arunachal Pradesh, which is in 2010. She has published many many research papers in SEI and Scopus. She has been a professor here, assistant professor at SOA, and now she's working as an assistant professor in CSE department at NIT Silchar. Ma'am, thank you so much for giving us your time, and I request you to start your session today.
Thank you, Dr. Madhurila. Good afternoon to all. Respected HOD Professor Devavati Mishra, HOD CSE, ITER Shiksha Anushandan, uh, senior faculties, colleagues, scholars, and my dear students. Today, my topic will be on authentication and key management schemes in a wireless sensor network. Ma'am, can you see the my PPT?
Ma'am, you need to share it. I think now
Uh,
it
okay,
needs.
can you see now?
It yes, ma'am, it is.
So my topic is on this authentication and key management schemes in a wireless sensor network. So they contain that is introduction to the wireless sensor network, types of authentication, types of attacks, security required in the wireless sensor network, security flaws of existing scheme that is Chukhu address scheme and update the scheme, conclusion, future works and reference. So these are the content that we are going to cover for 45 minutes. So just come to this before proceedings with this to look at a scheme. That means we are going to find out some security flaws of doing public and health. So before that, we need to know some basic things about the by the wireless sensor network, what are the types of authentication, types of attacks and why we need the security in the wireless sensor networks. Okay, then we will come to with this two-knobic attack scheme. Means we are going to find out some security flaw and then we will be updating that scheme and then we'll come to some conclusions. Okay, so here just you see what is mean by wireless sensor network. Again, here before the wireless sensor network, we need to know what does mean by sensor device. So we can say the sensor device is a small device capable of sensing the real physical and responding to the some types of input from the physical environment. The input can be of anything that is light, heat, motion, moisture, pressure, gas, sound, or any environmental condition. And again, one more thing that is the sensor are very resource constrained. So in our research paper, we are going to concentrate on the sensor node. That means it is resource constrained, so we are going to minimize it. Okay, that is we are going to reduce the amount of computing abilities and the duration of battery is also very less in this sensor Yes. So now come to the picture, that is wireless sensor network. What does mean by the wireless sensor network? It is an infrastructure-less wireless network that is deployed in a large number of wireless sensors in an ad hoc manner that is used to monitor the system and the physical or the environment. So come to these architectures of this wireless sensor network, that is generic wireless sensor network architecture. Here you can see this is the WSN part where the sensor nodes deployed this environment randomly. Okay, randomly you are deploying the sensor in this WSN, and then sensor node transmitted the real data to the gateway node, that is this is the gateway node, and the real data can be assembled by the user through the help of this gateway node. Or you can say this gateway node as a sync node, means it will collect the real data from this environment and then it will send to the gateway node. Okay. And we can say this gateway node also play a very big role in the wireless sensor network. That means we consider this is of trusted WCW, that is gateway node. Okay, and it has the higher computing capabilities, large storage space, and access point for the human interference, which make it more attractive in a wireless sensor network. And this is managing this what called secure communication between the user and then these nodes. Okay, so here from this it will connect it with the internet and then user, and then this user will be getting all the information that is sensed by these sensor networks. So just come to the characteristics of wireless sensor node. Like this sensor node has a limited consumption of the batteries, capability to handle the sensor nodes may be failure, or it will be distributed on large scale, capacity to attain the restricted environment, and flexibilities of nodes and the nodes of diverse quality, and easy to establish this sensor nodes in the wireless sensor networks. So some few applications of wireless sensor networks are in military, healthcare, security and surveillance, industrial, smart home, entertainment, and precious agriculture and animal tracking. So these are some applications can be seen in the wireless sensor network. And there are two types of this wireless sensor network, that is distributed wireless sensor network and the hierarchical wireless sensor network. So here in this research area, we are going to concentrate on these distributed wireless sensor networks. So as you see some limitations also, that is the security issue. What does mean by security issue that can be seen in the wireless sensor network? That is, in wireless sensor network can be not secure as compared to the wired communication network. So limited resource already we have discussed. That means limited memory or the storage space and low computing process it will have. And low communication capabilities means sensor node has the short range communication using the radio frequency or the infrared. And it has the less transfer speed or a bandwidth which makes it hard to transmit the large amount of data. And the fourth point is battery lifetime issue. Again, the sensor node battery life is extremely low. Okay, and then destruction. Communication channel may get disrupted by other wireless devices because of distributed wireless sensor network. That example can be considered as of Bluetooth and not capture attacks. That means what does mean not capture attack? That means sensor node does not have the properties of temper resistance hardware, and then sensor nodes are deployed in unattended region or the critical environment. Okay, so in that case, this what node capturing attack can be done in wireless sensor network. lack of information on the post-deployment configuration. That means it will be deployed in the very large territories and the individual sensor are deployed. That will be randomly it will be deployed, and it is very hard to know the position of that particular sensor reference. Okay, so means each and every sensor it will be difficult. So come to the next topic, next slide, that is security flaws in wireless sensor network. What are the security flaws can be seen in the wireless sensor network? That is the main challenge issue is the sensor network, the security part. Okay, that means we are going to consider some authentications, confidentiality, integrity that we are going to consider in this. Okay, and wireless sensor network is highly suffering from some security attacks due to the unavailable communication, connection, and unattended or the neglected operation. These are some security parts. Now come to these types of user authentication. Means what are the types of authentication considered? Okay, so again we are merging these types of authentication in a wireless sensor network also, because we are going to create a network where there will be a user, then gateway node, and then sensor node. So before proceeding with that scenario, again we need to know what are the user authentication types. So here password based authentication. So in this picture you can say the user has to be entered. User has to be entered the user ID and the password, and server will verify the user password, and it will send or it will give an authorization to the user, and then the authentication is given to the user from the server. So this is the password based authentication. Now move to the smart card based authentication. It is similar to the credit card, okay, that contain a microprocessor chips, okay, and which has the storage space for private key or personal identification number, that is PIN, and public key certificate and other personal information that is used to identify the user securely. So here again just you can see the user has to enter the smart card into the card reader, and the card reader forwarded that uh, forwarded to the server, and the server will verify that particular user, and then again it will authorize the user, and then authentication is given to the user. OTP based authentication using smart card. So in OTP based authentication using smart card, here you can again see it will have the OTP, that means one time password. So just you see the user again entered the identifying the password and then smart card, and it is sending to the server. Okay, it will be sending some request to the server, and then server will again send the OTP to the user, particular user, through the mail or through the sending in personal mobile number. Okay, and then again once the OTP is verified at the server side, then the server will give the authentication or authorization to this particular user to access the server. Biometric based authentication. So you well aware of this biometric based authentication means biometric means the personal identity is verified by biological unique identifier, and that identifier can be of fingerprint, voice, iris, retina, face, bend shape, and etc. Okay, so here again user has to enter his or her the biometric features, and the server will verify that particular this biometric of that particular user, and then again it will authorize the user, and then communication can be done with this user and then server. So multi-factor authentication. So what does it mean by multi-factor factor authentication? Here again, user has to be combine any of the authentication from this, that is like OTP, biometric, or password. Okay, so here we are considering there is password, PIN, or OTP, or biometric. Here we are considering the three parameters: the password, PIN, and biometric. So that user is entering, user enter this call PIN and password and biometric to the server, and server will verify the password of the user and PIN and biometric, and it will be authorized again to the user, and then user can use the whatever they want to access the information, they can access it. Okay, or you can say the authorization is given to the both the user, means both this user and the user can access any information he or she requires. So authentication model. So here you can see the authentication model, that is A, B, C, D and E. You can consider any of this authentication model, and then you can consider or you can propose one model. So in this case you can see this is the user, this is the gateway and this is the sensor node. Okay, so here from this you can see I have given from 1 2, means it will user will send a request to the server, not server, gateway node, and again gateway will be sending to the sensor node, and then again sensor will sending back to the gateway node, and then again it is giving the authentication to the user. But in our proposed model, we are going to consider any one of this authentication model. Okay. So here you can see this B one we are considering. We are going to consider this authentication model. That means the user will send the parameters to the gateway node for the authorization, and then again gateway node will be sending to the gateway node will be get back the reply to the user, and then again this gateway is sending the this. Okay, that is sensor node. Again, there is an authentication between this user and then sensor. Okay, so just come to these types of attacks can be possible in a wireless sensor networks. Okay, so just see the first is stolen or the lost smart card attack. So types of attack. So just you say attacker will attempt to get the user information like the user identity and a password to access the advantage. So how you will overcome this stolen smart card attack can be done through the credential value stored in the server must be complicated, and it should be an XOR function and secure the information using the cryptographic one-way hash function. And that is password guessing attack or brute force attack. So we know that the brute force, what does mean by brute force attack? Means adversary will try to figure out the user password by exhaustively searching the technique in a offline. Okay, and we can say what does how you will identify this is a password guessing attack. That can be through the dictionary based password guessing attack. Okay, it is easily to crack the password because the common word are used and publicly available. The countermeasure, or you can say how you will find out the solution for this. That is, the password must be include the special character, symbol, upper, lowercase, minimum of 12 characters, unique number. Password must be updated for the every 3 months and avoid the reusing of the old password. Even use the captcha while logging into the system. That is duplicated. The third party records the previous transmitted message and later transfer the same message during the protocol execution, and receiver believe that the message is from the legal user, that is new. And examples can be user login to the mail using the user credential identity and password, and attacker can get the credential and resend the information after some time. The countermeasure can be to avoid the replay attacks at the timestamp at the both sides, that is at the sender and the receiver side. Mainly middle attack. The fourth number mainly middle attack. That means it will be attacker will place themselves between the communicating two parties, and it will be make some alteration. The alteration, whatever the information that is here between the both the sender and receiver, and both the sender and receiver will not know that this communication is from the adversary or the third person, and then in that case the main in the middle attack can be occurred. Okay, and countermeasure, that is the verification technique has to be done and making a transmitted parameter complicated. and information must be encrypted form and timestamp facility for the both the client and server, and additional one, that is one-way cache function can be included. Denial of the service attack. In those attacks, the network or the systems are intentionally shut down by the attackers to make the legitimate user or valid user inaccessible to the network. What are the countermeasures? Countermeasure, they use the strong encryption method like AES to resist eavesdropping, and files must be hashed. Second, disable the unused and insecure services. Install the software intrusion detection system (ITS) and intrusion protection systems to monitor the malicious violation and then activities, and also up to date the robust antivirus software. The session key attack. So this is also one of the important attacks that has to be considered in the protocol that we have done. That is, attacker trying to get the valid session key or some portion of the network or the session and act as an active participation in the communication to access the server. So in this case, again, the countermeasure is that session key must be kept in secret, and during the session key generation, made unavailable to the adversary to get the secret parameters. A session key must be various credential like it should include the credential like random, number, timestamp, secret key, and biometric identity. That is impersonation attack. So we will not go with the impersonation attack. You well know this. And then just go to the sensor node capture attack. This is also one of the important. Okay, so here you can see sensor node capture attack means adversary node directly compromise the targeted sensor node and retrieve the stored information such as the program data, encrypted key, computational capacity, and instructing the nodes and receive the information from the other nodes. Later, the malicious attacker removes the capture node from the network and drain the power of the entire network and redeploy it with the new sensor node. So the countermeasure, it has to vaporize the sensor node memory content and destroy itself. Additionally, you can do that the network must be activate the self-destruction technique to expel the malicious node from the network. The security requirements in wireless sensor network. Why we are considering this security in a wireless sensor network? So we know that in today's world, fast increasing in the utilization of internet and the publicly availabilities of service through the Internet of Things are increasing drastically. And due to the publicly availabilities of service, vulnerable to share information become a burning issue in a distributed environment, and possibilities of hackings are increasing day by day. Therefore, in public network, we need to protect the unauthorized user and hence the integrity and security reputation norm. Security and confidentiality are the important factors in a wireless sensor network. Okay. In the security aspect, authentication is considered one of the fundamental requirements of sharing the information is a big challenging issue, and it is necessary to verify the session key trade between the two parties, and key agreement protocol is one of the entity which enables the communication safely over insecure wireless network. And sensor node is defined as resource constraints also. Okay, and we have to improve that sensor node. So just come to this yeah, trade model that we have considered. So trade model that we have considered is that the scheme we use this dollar trade model. Okay, so this is the dollar trade model, and this dollar trade model includes that the adversary has total authority to interpret or modify, delete the message during the communication. And also adversary may eavesdrop on the channel and if possible calculate the long-term session key and the secret key to make the entire protocol faulty. And again we know here again threat model we are including that the sensor node is are the resource constraints in nature. Okay. So gateway node we are considering again the gateway node will be can be never be captured or negotiated by the adversary because once the this gateway node is compromised then the entire network will back down. Okay, and smart card can be stolen by the attacker. Okay, and perform the power analysis to gain the information about the smart card credential. So this is the threat model we have considered. Okay, and then come to this mathematical preliminary, that is collision-free one-way hash function. That compression function takes an arbitrary variable length input string and perform some algorithm and arithmetic operation on it to convert the fixed length into the binary sequence. Okay, and biohash function we are considering the biohashing for the security purpose. We have used this hash function, or you can say the collision function and the biometric hash function. So this is the double one notation and the symbol that we have considered for the proposed model. Okay. Or the existing model. So here you need to see this is SK underscore GWN. This is the secret key of GWN. And GWNPSJ, it is the secret key of GWN shared with the SJ. SJ means it is a sensor node, UI means user, and this SCI means the user smart card. Okay, and then BIOI is the biometric features of the user. This is the password, and TX is the current timestamp, and delta T is the allowed transmission delay, and SK means session key, and H, this is hash function, VH, that is biohash function, and comparing for the comparing purpose X equal to Y or not for the authentication purpose, and then we are using the XOR to perform the XOR operation, and then concatenation operation we are using. So, doing the research, we have found that in authentication and key agreements in wireless sensor network, we have found some security flaws. Like some of the attacks can be performed in that Atal scheme, that is like sensor node capture attack with the malicious node correction, hash function calculation problem, and denial of service attack, insecure login phase, insufficient password change phase, identity theft attack leading to loss of anonymity, and use of timestamps. So these are the some drawbacks or the security flaws that we found in the toolknowledge at all. And then we have updated this existing scheme with the efficient. Okay, so here we have already calculated for this how the sensor node is captured by the attacker. So here you can see attacker can easily launch a sensor node capture attack by compromising the sensor node and retrieve the value of SIDJ and GW and P underscore SJ from the memory of the sensor. Or it can drain the power of the active sensor and drain the power of the entire network. So hash function, again we have found there is some issue or there are problem during this performing hashing in the existing scheme, that this hash is not equal to this hash. So in updated scheme we have changed this also, and use of timestamp, that means time synchronization problem. So authentication and verification cannot be done if the time stamp is lost. So in updated scheme, we have avoid to use this timestamp also. denial of service attack. So again here we have considered and then we found out the drawbacks, or you can say those attack can be performed in the Chukhu attack scheme. Insecure login again here you logging in that case again it's found it is an insecure through using some calculation. An identity thief attack leading to the loss of anonymity. Thus, the identity of the user is not verified and can be guessed the identifier of the user. And after computation, this we have compared this edge RI concatenate UIDI with this. Okay, and then we can get the original identity of user. So we can say this model is not that much secure. So a loss of anonymity can be find it in the two-economic catalyst scheme. So come to this. That is the updated scheme. The updated scheme we can consider secure biometric-based user authentication schemes in wireless sensor network using a smart card. So here you are using this biometric and then smart card. Okay, so well, performing this authentication and key agreement scheme in wireless sensor network, there are 6 phases, that is pre-deployment phases, registration phases, login phases, authentication and key agreement phase, and password change and dynamic addition of nodes. So here in updated scheme we have added this provision to change the password also, and then again you can add a node in the networks. Okay. So pre-deployment phase, what does mean by pre-deployment phase? Before things get to start, the administrator need to fix the environment using the setup server. Okay, the phase run offline where each regular sensor SJ is provided with their IDJ, that is the identity of the sensor, and the pre-shared the secret key, that is GWNP underscore SJ, and then generated the randomly and stored securely in the memory of the GWM. Okay, this GWM, we know that initially we have gone through this. It is a trusted server and it cannot be attacked or compromised by any of the attacker. If it is compromised, that means the model, or you can say whole system, will be collapsed. Okay. So as you see, the second is that registrations of user and sensor node. So just you see here UI, I have given in this in table form. Okay, UI, GWN and SK. So UI will be storing his own user ID, password and the biometric, and in GWN in database it will be storing the secret key GWNP underscore SJ. This is the secret key that is here between this GWN and then SJ. And SID means identity of sensor node, and SK underscore GWN, this is also a secret key of GWN, and GWNP underscore UI, this is a secret key that is shared between the user and GWNP. Now, the user has to be compute this MIDI equal to hash of UIDI concatenate with the RI, and again PWDI equal to hash of U PWDI concatenate with the RI, and then you have to send this MID and the MPWDI parameters to the GWN. So this is a registration phase, okay? And MI equal to MI. Then after receiving this MPWDI MID, it will compute MI. MI is equal to hash of MIDI concatenate MPWDI XOR with the GWNP underscore UI and XI, and it will compute the XI also, and then it will store like MI X XI has into the smart card, and then it will sending to the UI. Okay, UI of the smart card. This parameters is going to be stored in the smart card, and it is sending to this UI. Then DWN will compute the DWNP underscore UI equal to MI XOR with this, and then it is entering the biometric also IMGI equal to VH RI XOR with the VI, that is the biohashing. Okay, biohashings of the user, and then it will compute the RI XI, and then it will store the value, or you can say the parameter, or you can say the credential, that is MI XI VH, and has II and AI in the smart card. Now you can see the registration of the user is done. Now again the registration of SJ has to be done. In that case, again just you see SJ compute MXIJ equal to S of SIDJ RJ GWNP underscore SI, and MYJ equal to RJ XOR with the GWNP underscore SJ, and send the SID J and MXJ and MYJ to the GWN. Okay, that is gateway node, and then again gateway node will compute RJ and XI MXJ PJ, and it will store the PJ in its memory, means in the GWN, and it will send the PJ to the securely to the SJ. That is SJ means sensor node. Now, after this registrations of user and then sensor, now what is the task? That is, the user has to be logging into the SJ. Okay, logging into the sensor node. So user has to enter his ID, okay, and then PWDI and the biohashing, and then it again compute the RI and the biohashing, and then we compute GWNP underscore UI, and where this is equal to MIDI star is equal to hash of UIDI star XOR concatenate with the RI. Okay, it will check here, and again it will check this also hash of GWNP underscore UI concatenate with the hash. If it is equal with the I, then user has given the, means user has the valid biometric and then secret key of the GWN. Okay, then it will compute MI, M1, M2, and it will send this MID and M1 and M2 to the SJ, and SJ will compute M3 and M4, and again SDIJ, MID, MIDI, M1, M2, M3, and M4 to the GWN, that is in gateway node. And again the gateway node will be verifying the user and the sensor. Again it will verify here through XI star, that is R1 star, that is random. Random value is also checked here, and then again R2 star equal to M3 XOR with the PJ, and again M1 and M4 is checked here. That is, here you can see this is for the user is checked, and here the sensor is checked. Once the user and sensor is checked here, validated here, then it will again compute the M5 and 6 and P1 and P2, and then again it will sense this M5 and 6, MP1 and P2 to the SJ. Once SJ will be receive this M5, M6 and P1 and P2, then again it will compute the R1 star and get the P1 XOR with the PJ, and X of I star equal to P2 XOR with the hash of PJ and R2 and R1 and R3 star, and then again it will check here. Check the authentications of SJ, whether this is valid SJ or not. In this, it will check with the M6. If it is yes, then it will create a session key, that is hash of XI star concatenate PJ and R3 star concatenate R2 concatenate R1 star. And then again, once the session key is generated for the SJ, now again it will compute M7, M8, M9, and then M7, M8, M9 is sent to the user. And then again, user will perform retrieve the value of this M7 XOR with XI. Okay, so this R2 star and PJ concatenate R3 equal to M8 XOR R2 star. And again it will check to the user. User will check over here. Again M9 equal to hash of R1 and R2. But this, yes, this is the particular UI. Then again it will create a session key, that is so xi pj concatenate with the R3 concatenate with the R2 star and R1. Okay, so the session key is shared between the UI and SJ. So this is the portions of authentication and key agreement that is done between UI and SJ. Password change. How you will be changing the password? That is, you have to enter the old password and provide your biometric, and again you can update the value of password AI new, MI new, where MPWDI new equal to hash of UPWDI new concatenate RI dates. Okay, that means finally you can replace the MI AI with the new MI new and the AI new respectively into the smart card. And again, dynamic node addition. The dynamic node addition means in WSN you can add the node as much as you need node, you can deploy it. And that particular environment, that means nodes to be dynamically append to the system without provoking any alterations in the established security state. So here node eventually stop operating due to the energy drainage or hardware or something malfunction. In that case, you can add the sensor nodes in that particular area. Yes, security analysis. So here you can see the security analysis also. Here we have done like formal security analysis and then again the informal security analysis also. And if we perform informal security analysis, we found that there is some we have achieved like resilience to the not capturing attack means we have that means it will be like node will be vaporizing its memory content or destroy itself while it is captured by an adversity. Okay, means within some time it will be destroying themselves. Okay, so some mechanism we have put in this node, sensor node, and then we have find out the solution to the hash function problem that is found in the Chukhu method. And then again the masquerade attack can be also prevented in our protocol, and then those attack and identity protection and secure. That identity protection means during the login phase. Okay, during the login phase we have found in Chukhu navigator it was not that much secure. Okay, we got the some identity of the user, but in this case we are hashing the UID and concatenate with the RI, so that means we are achieving the identity protection also. And secure login login password change phase, we can securely we can change the password. Mutual authentication and key agreement, that is the session key that is negotiated between the two that is user and the sensor. okay, through the insecure channel. This can be achieved, and resilience to the eavesdropping attack. And so here again, very informal analysis, we have gone through with some this Boro Avadhi within logic, where we have checked this whether this our proposed model is secure or not. Okay, for that we have performed the band logic. So here you can say we have set the some goal that UI believes the SJ, then SJ believes that UI and SJ is sharing the session key. And again UI believes that the UI means this is user, okay, and the sensor is sharing the session secret key. And again, SJ believes that the UI and the UI believes that the UI and the SJ is sharing a session secret key. So these are the four goals we need to achieve in the band logic. And there are some rules also. So I'm not going to explain this. So some communication message encryption we have taken. So and then again we have done with this probe tools also for the checking the this whether our protocol achieve this achieve like whether it is prone to some attacks or not. So through this probe we have like checked, and then we know that our schemes doesn't detect any of the attacks in this proposed model. So here you can see this we have considered this the GWNP UI. This is the secret key of the UI and secret key that is shared between the SJ, and the secret key of the GWN and the PJ. These all are unreachable by the attacker. When you are performing the simulation, you will find out this all are the unreachables. Okay. So again, we have done some performance evaluations of proposed model. So here we have compared with the two-knobic Excel scheme, the Geo Excel and the DAS Excel, and then most of the time we can see the security feature that is satisfied in our proposed model, or in the research you can see these are the some attacks can be prevented in the this updated scheme. Communication cost of our schemes with the other related scheme. Again, here you can see the in GeoITER it has a 6 message, but in case of our it is a 4. Okay, and then cost of message exchange also. Here also again you can see cost of message exchange. So here you can see it is of 60 bytes, 20 bytes, 80, and 60. Okay. And computation cost in terms of hash function. Again, we have checked the hash function, how many hash function that we are considering, that is also calculated over here. And then memory head comparison during the completions of the registration, after receiving the message from the authentication of the user, and calculation performed after the authentication message received, and getting a knowledge from the gateway nodes, and calculate after just accepting the acknowledgement from the GWN. That means pick up the moments that is the in the user gateway node and the sensor that we have considered over here. Okay, so here also you can see this two-economic appeal and then proposed model we have compared. Almost it is same, but in case just you can see calculation 60 bytes memory overhead, and this is of the 120. And we know that the memory size should be reduced in case of the sensor nodes. So we have done the conclusion. Security is the most concerns in today's world, especially in the wireless sensor network environment. And the basic factors which determine the secure communication are integrity, confidentiality, availability, and non-repetition, authentication, and session key agreements. And as per the study, in a wireless sensor network may suffer from numerous malicious attacks due to the distributed network and the resource constraints in the features of sensor. Therefore, to remove the security flaws of existing schemes, some new cryptographic protocol have been proposed, and that for informal security analysis and mutual authentication is done using the done logic, and the simulation is done through the probability to check the truthiness of the protocol. And these are the some features what you can do in the ad hoc network. Deployed of the sensor is always challenging issue. Okay, so you can work on this ad hoc network, or then addition how you will dynamically aid the nodes in that particular duration is also one of the challenging tasks. And then again you can work with some you can design some proposed model that is very lightweighted, And again, you can we have focus on the session key also. So again, you can work on the session key, how you will be generating the session key in the both the side, that is user and then sensor side, automatically how you will be generating that session key. That can be also considered in a future work. So these are some reference. Thank you.
Thank you, ma'am. We are open for questions. Anybody has any questions?
Yeah, good evening, ma'am. Am I audible?
Yes.
Yeah,
Yes, sir.
actually, nice explanation for that, giving basic concepts of different types of attacks and wireless sensor network. Uh, so my question is, uh, different types of attacks can be possible for any sensor network.
Hmm.
So question is that, at what time interval or regularly we are going to monitor the attacks? Is this not a constraint for the energy for a WSN? Or any specific interval exists that we must check at this interval this type of attack like that?
No, no, there is no any kind of interval will be given in that interval there will be an attack will be occurred. Okay, but in case like if you consider this wireless sensor now, power analysis. Okay, power analysis in power analysis attack. Just you can check with this also. In that case, if you capture this sensor node, okay, if you can capture the
Okay.
sensor node and if you perform an power analysis like frequency, how much frequency is generating oscillation, okay, in case you can perform an attacks on a particular sensor also, but there is no any specific time that in that time you are going to perform and that particular attacks, okay. And then again
Okay.
uh, okay, then I think this is
So that
enough.
means I can say that when the performance is going to hamper, in that case we can check for the attacks. I think so.
Yeah, yeah. Anytime attack can be happen in any time.
Okay. 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 Thank you, ma'am.
Hmm. Thank you. Any question?
Perhaps at this point of time, I don't think students will come up with a question, but they do follow and if there are any questions, we can take now. Otherwise, you can also type it in the chat box. We are just, I think the presentation is so well.
Any question?
Thank you, ma'am. Divya? Hello,
Yes, ma'am.
ma'am. I think I was on mute. I wanted to give the vote of thanks. I would like to thank everyone who has joined here. I would like to thank you, ma'am, for taking out the time to join us. And I would like to thank our HOD and our senior professors here and the whole idea of how these webinars are being arranged and conducted. Thank you so much, ma'am.
Thank you, ma'am, for giving me this opportunity
We'll be in
to
touch, ma'am.
my this. At least I can share my what I have done in my research work. Thank you, ma'am.
Thank you, ma'am.
Ma'am, now can we leave the
Yes,
meeting?
we can leave. Thank you, ma'am. Yes, ma'am.
Thank you, everyone.